right, we are almost done with our notes for this chapter. Today we are looking at how to prove that two triangles are similar to each other. And we have three ways to do that. And they sound very similar to the ones when we were proving congruent triangles, which is why when we were proving congruent triangles, I stressed that it's not SSS, it's SSS congruence. So very similar to that, we're going to do AA similarity, SSS similarity, and SAS similarity. So you do need to make sure that similarity is in there. So AA, well, angle, angle, which basically says if you have two angles of one triangle congruent to two angles of another triangle, then those two triangles are similar to each other by AA similarity. Okay. SSS works a bit differently than when we were doing congruent, because this time we don't want the sides congruent to each other, we want them proportional to each other. Okay, so looking at these two triangles, they're not the same size, but if we set up proportions between the sides of the triangles, those end up being equal to each other. So AC over DO equals AT over OG equals CT over DG. So if that's true, if all three ratios are equal to each other, then the triangles are similar by SSS similarity. And the last one is SAS. Well, it still stands for side angle side, but this time the sides are not congruent, the sides are proportional. But the angle still has to be congruent. So we have a congruent pair of angles, and then the sides on either side of the angles have to be proportional. So CO over PI has to equal OW over IG. And it has to be the two sides that are attached to the angle, because the angle has to be between those two sides. All right, so for our examples, we're going to decide which of these we think we're going to try depending on what information we have, and decide if the two triangles are similar or not. If they are similar, we're going to write a similarity statement. So looking at these two triangles, all we have are the sides, which means we're going to have to try SSS similarity. And you need to look at the size of the sides. So I did the two shortest sides together, so 30 over 50 reduces to 3/5. I did the two middle sides together, 39 over 65 reduces to 3/5. And I did the two longest sides together, 42 over 70 also reduces to 3/5. All three ratios are the same, which means yes, the triangles are similar by SSS similarity. And similarity statement, the first triangle you can name in any order. So I just said triangle KLM. The second triangle, like when we did congruent triangles, you need to make sure you look at the corresponding sides to put those letters in the correct order. So it would be triangle FED. If I'd put the L first and said like LKM, then this one would have to be EFD. So you do want to make sure the letters are in the correct order. All right, so looking at example 2, well, this time we have two pairs of sides and the included angle. So the included angle has to be congruent, and they do have the same measurement. Angle R is congruent to angle T. So then I want to do the sides and see if they're proportional to each other. So I have 8 over 24, which reduces to 1/3. And I have 14 over 42, which also reduces to 1/3. So yes, the triangles are similar by SAS similarity. And I named it triangle PRQ is similar to triangle VTU. So the key is the P has to line up with the V, the R has to line up with the T, and the Q has to line up with the U. All right, so that's it for page 1.